All right, we're going to conclude our study of geometry by looking at volume and a little bit with surface area. The second page of your handout has the volume formulas. I will use the formal names for these. You'll just recognize them as probably something different. Number 1 says define the volume of the figure. There we go. And this figure, which is commonly called a box, is actually known as a rectangular prism. Formula. Volume is equal to, you've got the base and the height. All volumes revolve around the idea of area of the base times the height. But what we're going to call it is length, width, height. It doesn't matter. I'm going to call that my length, that my width, and it makes sense for that to be my height. So the volume is 4 feet times 4 feet times 7 feet. With my calculator, I will multiply those and get 112 feet to the third power, cubic feet. That's a prism or a box. If all the dimensions are the same, it's called a cube. All right, let's look at number 2. I tried to vary the shapes. Number 2 is called a pyramid, and it has a rectangular base. What you do, and this probably sounds a little weird, but I have always thought of it this way. If the shape comes to a point, like a pyramid or like a cone, if it comes to a point, you find the area of the base, you multiply it by the height, and you take 1/3 of it. Always 1/3. Okay, so the volume is 1/3 times area of the base, whatever shape it is, times the height. So it is 1/3 times. How would you get the area of that base? What is the base? It's a little rectangle. So it's going to be 6 meters times 8 meters. That'll be the area of the base. And the height is 16 meters. If you have a sophisticated calculator, you just type this in there. You don't even have to have parentheses. But I did it on the notes that you might look at. I did it kind of by hand, did it step by step. But if you do all this, you will end up with 256 meters cubed. You can, instead of multiplying by 1/3, you can multiply these 3 numbers and divide by 3. Multiplying by 1/3 is the same as dividing by 3. And it is in cubic meters. So your job, remember that you're going to take 1/3 of it because it comes to a point. That's how I remember that. I actually won in a contest, a trivia contest. Well, I was part of a team, and the rest of the team was really, really good at trivia. But then there was one, how do you find the volume of a pyramid? I was like, I got this one. I got it. And most of the people didn't. Where'd you get the 1/3? Okay, it's because I teach. All right, how am I going to find the volume of this can-looking thing? Is a cylinder. The formulas are on your sheet. The volume of a cylinder, it's the area of the base, which is pi r squared, times the height, because it had a circle bottom. Thank goodness they are telling me to use 3.14 as the value of pi. So the volume is 3.14 times, do you know the radius? 5 centimeters. I'm going to need to square that, times the height, which is 9 centimeters. Probably in the notes, I went ahead and did the squaring and did 3.14 times 25 centimeters squared times 9 centimeters, which is 706.5 centimeters cubed. You've got to look at my math lab to see in blue it gives you the interesting fact that you've got to have round to the nearest whole number. This is going to be approximately 707 centimeters cubed. All right, what are we going to do different? How is number 4 different than number 3? Still a cylinder. Somebody rolled it on its side, but this is kind of important. Volume is pi r squared times the height. And I want you to watch for this in all problems that involve circular surfaces. Pi is 3.14. Were you given the radius of the circular bottom or top? Were you given the radius? Remember, in a circle, the radius is from the center out. Sorry about my bad circles. The diameter is all the way across. Are you given, which one are you given? The diameter, because it goes from here all the way across. So when it asks for the radius, you have got to cut it, that diameter, in half. I think that is in one of your circle questions from the last lesson that I didn't mention. Watch for that. So the radius is 6 inches squared and the height is 9 inches because they turned this thing on its side. So did I make a big enough deal about this? The formula needs radius. If I give you the diameter, you must chop it in half. If it's an odd number, you're going to have a decimal. Okay, so then we do our calculations, and you will get 1017.36 inches to the third power, round to the nearest whole number. That's 1017 cubic inches. Okay. Okay, next one, volume of a cone. Cone comes to a point. That means there's going to be a 1/3 in it. So the volume is, and you can just look it up, it is 1/3 pi r squared h. It is still the area of the bottom times the height, but because it went to a point, it's only 1/3 of the volume. Do you have all the numbers you need? It is 1/3 times 3.14 times the radius squared, that's 2 centimeters squared, times the height, 6 centimeters. If you want to, you can multiply all these numbers, the pi, the radius squared, and the height, and then divide by 3. Or you can put 1 divided by 3 on your calculator. And you will get, for this one, 25.12 centimeters to the third power. Oops, round to the nearest whole number, 25 cubic centimeters. I'm moving kind of quickly. Are we okay? Are y'all okay? All right, what's different about 6? Oh, well, they turned the cone upside down. What did they give you? You've got the height. You know that volume is 1/3 pi r squared h. Volume is 1/3 times 3.14 times What's the radius of this cone? This is the diameter all the way across the circle. So the radius is 12 centimeters. Make yourself a note, even if it's a mental note, you gotta know the radius. So it is 12 centimeters squared times the height, which is 8 centimeters. Multiply all that, divide by 3, and you will get 1,205.76 centimeters cubed. Round to the nearest whole number, 1206 centimeters cubed. All right. Numbers 7 and 8, which are the last two, you might say it's a ball, or that it's, well, these aren't the last two, I'm sorry. There really are others. This is a sphere. The formula for the volume of a sphere is really weird, and it takes a little calculus to come up with it. But we're not going to have to come up with it. We're just going to have to be able to use it. The volume of a sphere is 4 pi r cubed divided by 3. Usually the formula is written as 4/3 pi r cubed. But I go ahead and say, how about 4 times pi times r cubed, and whatever you get, divide by 3. So for this one, we have 4 times 3.14 times 5 centimeters cubed. And whatever I get, I'll divide by 3. Be sure that you cube the 5. You can do it in your head. You can do it on your calculator. 5 times 5 times 5 is 125. This turns out to be, and I let my calculator do it, 523 centimeters cubed. It came out as a whole number. I didn't have to round. Practice with your calculator. Make sure you can use it when you're testing. You want it to be your best friend, not your enemy, whatever kind of calculator you're using. Visit with me in class and I'll help you if you're not sure. All right, what's different about this sphere? It's still 4 pi r cubed over 3. What jumps out at you? I'll just start. We'll see. 4 times 3.14 times the radius cubed. Do you have the radius? You're given the diameter. The radius is only 5 centimeters. So 5 centimeters cubed over 3. And this is actually now the same problem as the one above it. Because the radius was 5 up here, the radius is 5 down here. Those are the same spheres. That won't necessarily happen in your homework. All right, this is actually number 9. And I may leave this one for you to kind of explore on your own. We'll talk about it a little bit, and then you can ask me questions about it tomorrow if you have any. This is one of those irregular volumes. This is an ice cream cone or a snow cone. The top of it, I'm not going to be able to draw it well, but the top of it's kind of like that. Oh, that looks really bad. Doesn't look much better. The top of that thing, What is that shape? Half of a sphere? The top of this is half of a sphere. Find the volume of the sphere and divide it by 2. What is the bottom part? It's a cone. Half a sphere plus a cone. I will leave that for you to have fun with. The last problem, surface area. Surface area is area of all the sides of a three-dimensional figure. We can do surface areas of lots of things. We're only going to do the surface area of a box. How many sides does a box have? 6. Okay, it has what I'm going to call a front and back. It has an end and a top and a bottom. Now, your formula sheet has the surface area of this figure is, and I don't usually use this, but I will, it says it's 2LW plus 2LH plus 2WH. Okay. If the bottom is a length and a width, there's 2 of those. It's the top and the bottom. If we call this the height, you've got 2 LHs, that'll be the 2 ends. You've got 2 WHs, those will be the top and the bottom. All right, let's plug them in. That's 2, the length is 11 meters, the width is 5 meters, plus 2, the length is 11 meters, the height is 10 meters, plus 2, the width is 5 meters, and the height is 10 meters. Now I followed the formula and I get 110 meters squared plus 220 meters squared plus 100 meters squared. Come on. Which is a total of 430 meters squared. But I will tell you, if it's just me, that's not how I do it. I literally look at it and say, let me find the area of the bottom and I'll double it for the top. Let me find the area of the ends and I'll double it for both ends. Let me do the front, I'll double it for the back, and I'll add those. It's the same quantities, but I actually look at the picture rather than labeling them L, W, and H and just say I need this side, this side, this side, this side. I actually find the area of each one of the sides and add up those 6 things. Surface area. Okay. If you looked at the problem sets to print, you'd see 2 more problems, but I'm omitting those, and they are not in the video, and they are not, I did not do them on the lecture notes. So we are done with volumes.